or depth. It was beyond HD. It was, I don't know if it was 4K or somewhere in between.
I wonder if it depends on how much space I have available.
Oh, it could be.
Yeah, looks like it's recording right there. So, good. Awesome. Well, I thank y'all very much for coming. We'll go ahead and get started. I'm sure people will trickle in. The parking was really difficult today. I know, I was like, wow, so many people came here for the Space Society meeting, but I guess they're still looking for the room. So, anyway, this is our November meeting. And let's see, I thought I had a few opening remarks, and then we'll have Patricia talk about space weather. She's on her way. She'll be here shortly. We might actually switch space news with the weather. And then we have our feature speaker, Vickie, who's going to talk to us about food and also about her career in food science. And then we'll meet up at PJ's for discussions afterwards. And so I just want to talk a little bit about perspective. How many of y'all have read Hitchhiker's Guide to the Galaxy? Okay. 42 times. That's very precise. Anyway, I love this quote, space is big. Do y'all know the rest of it? How does it go?
Space is big, really big.
Oh, you just won't believe how vastly, hugely, mind-boggling big it is. I mean, you may think it's a long way down to the road to the chemist, which, you know, it's the same thing as, you know, yeah. But it's just peanuts compared to space. So I thought that was good. And, you know, just to kind of continue a little bit with Hitchhiker's Guide to the Galaxy. So this is what we think the galaxy looks like based upon looking at other spiral galaxies. But far out in the uncharted backwaters of the unfashionable end of the western spiral arm of the galaxy lies a small, unregarded yellow sun, just to put us in our place, you know. Orbiting this at a distance roughly 92 million miles, which basically is 148 million kilometers, so just to kind of put those together, is an utterly insignificant little blue-green planet whose ape-descendant life forms are so amazingly primitive that they still think digital watches are a pretty neat idea. And just to give you an idea on how far it is from the sun to the Earth, that 92 million miles, it takes about you know, 500 seconds for the light from the sun to reach the Earth, which is, and if you were to look at how wide the galaxy was, we think it's about 100 light years, 100,000 light years, which means that by the time the light from the stars on one side reached the other side, you know, a lot of time's passed. So that's kind of amazing. And ultimately, you know, we want to get to the next star. So if we look at the local stars, you can see these are some good first choices since they're closer. But even like the closest star is like 1 point something light years away. And you have a few others. But back up.
How recent is this chart?
That's a very good question. It was just downloaded from the internet.
Oh, well, yeah, just because I think I've seen this before in this. I think since this chart was generated, there are at least a handful of very small red dwarf stars that are somewhat closer. They're not, they're just scattered around, and they're still farther away than Alpha Centauri, but they're quite a bit closer than some of these other candidates here on this chart.
Yeah, so there may actually be more things to go and see. But ultimately, you know, getting to the next star means we need to get to the next planet. And Mars provides kind of like a tempting choice since, I mean, it has a 25-hour day and it does have an atmosphere, though it's thinner than, you know, even where the airplanes fly. So yeah, but and, you know, potentially, you know, if things go ultimately perfect over the next 26 years, we might have a significantly sized settlement on Mars this century. I don't know about 1 million people on Mars by 2050, but I heard those numbers tossed around. I thought that was pretty cool. But if you're interested in learning more about this opportunity and other things, you're always welcome to join the North Houston Space Society. There's a link there. And with that, I think we'll go to space weather. And let me bring up your presentation. Lower left.
I had to get rid of it. Oh, you found it.
Oh, this is just my slide.
Oh.
But is it on the? Oh, we did.
That's over here somewhere.
Oh, there we are. It's just a shortcut.
Yeah, I need access still.
But I also emailed it to you directly.
Oh, okay.
Yeah. Oh, there you go.
I did this.
I think it just maybe just click on it.
So there.
No, I mean maybe just click on it.
Oh, and here, that's true.
Yeah.
Need access.
You want to just do mine after Grace?
Okay.
Okay. Well, we'll still have the same. We still have to get this.
You want to just request access?
Yeah. They must have tightened up on security recently.
You got a mic?
Yeah.
Okay. Awesome.
How do I give you access?
You get an email?
You'll get an email, I guess. Stand by, please.
Okay. Sure. Cool. And then we can click on it. I mean, just click on the link again.
Oh, okay.
No worries.
I never
cool.
can find
Okay.
the other glasses.
So we need to put this over there.
There's a presentation view. Oh, and here you go.
Yeah, I don't know if this is going to work with this or not. Oh, it does. Okay. There you go.
Awesome.
Yay!
Beautiful.
Okay.
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 Oh, yes. I did that today. Oh. I meant to do that.
Okay. Hello, everyone. We are at very much so at solar maximum. We had almost 100 M flares this month, and that's like the mid-grade flare. We did have 4. How do I get to? Okay. Well, I have a slide there that has all 4 of the X flares that we had, and you can see, you can see both of these and the next 2, they all happened when the sunspots were about on the east limb. So we didn't get too much impact here on Earth. The 3.3, this one, and one of the M flares near it did give us an elevated proton storm, and that peaked around the 28th. And it just subsided a few days ago. We actually got up to the R2 radiation level, and that's where just some alerts, more interference on the ham radio bands and stuff like that. And we also have a lot of fast solar wind coming in from some corneal holes, which these are actually pretty big ones. And we are seeing, I think even the aurora from last night was from these guys, more so than an actual flare. And then I wanted to show y'all, sorry, my slides are all funky. I wanted to show y'all what we have currently going on. This is the current disk right now. And we do have two major sunspots going on. This is, I think this is 883 and this is 889. Yeah. And those are both the highest classification of sunspots. And as you can see, they're both just south of the equator. This one gave us this solar flare, the 2.3 on 11/6. And it definitely still has more in it. Where it is now, if it erupts, it will probably give us a good show. Not anything like May or October, but it'll give a good show at higher latitudes if it erupts because of where it is.
Protons moving about how fast?
It depends. The proton storm was separate from, it was a result of the solar flares, but it's separate from the auroras. The proton storms can actually happen immediately after a flare. And then they can go on for days depending on how much, how much was erupted. There's actually one of the lines on the, I don't have a graph of it. There's actually one of the lines that's known as the heart attack line on the proton graph. And that's because they have noticed an increase in cardiac emergencies when that goes up.
You're serious?
Yes. And like I said, the proton storms related but separate, kind of like how here on Earth we have wind and rain, and a storm can be more wind, a storm can be more rain, it can be a little mix of the two. It can have hail. There can be mist, and mist, rain, hail, all same things, just different forms of it. And it kind of works the same way. different densities and speeds of the plasma.
So we're getting electrons, and then which are traveling probably really fast, like 0.9 C. And then the protons are traveling probably slower at 0.8 C. And then, what else?
The protons
put out.
X-rays? Yes, the X-rays. The X-rays, I don't know all of them yet.
Oh, okay.
I am still learning. I have not trained as an anthropologist. There's a lot of levels, and I definitely don't have time to, but we can talk more after. But with these, I just wanted to show, these are the two dynamic spots that we currently have. Both of these spots have X-flare probabilities. This one right here, probably more so. And that is actually the incoming region. So as this region moves across the disk, we are going to have a higher chance for X-level flares. But just because it's an X-level flare doesn't mean it's necessarily eruptive with the plasma, although it might be eruptive with the protons.
So this solar is really not the same thing as prominence does.
No.
Prominences can be there. Sometimes yes, sometimes no. Okay. But the flare itself is really more like a old faithful guy straight up out of the sun.
Yes, and that is a great analogy for it, because you know how at Yellowstone there's always seismic activity going on.
Right.
There's always geysers that they have. It goes off every 45 minutes because they know it's reliable, and there's some that go off every few hundred years because of the more activity. And it's kind of the same way, and we're at solar maximum. I've compared the sun to a wiffle ball before, because there are like general regions that it tends to come out more, whereas like the sunspot number might not be the same because those change on every rotation. It is generally the same regions, kind of like the Gulf of Mexico is prone to hurricanes. and different storms, different times of year here on Earth in different locations. With the sun, the closer we get to solar maximum, the sunspots towards the equator tend to act up more. And
My memory again, the sun rotates once every how many days? Or
I believe it's 27 or 28 days.
28 days? Okay. All right. So we're able to figure out that some regions are more active.
Yes.
And this has got to be really difficult since there are no landmarks. Okay, all right.
Yeah.
How they figure that out.
Well, you kind of have to use the dynamic landmarks, like, okay, was that there the last time it came around? And just compare and contrast that way. There are, like right now, we don't have anything facing the far side. But sometimes we do. Sometimes we have more information coming from the far side and we have more information. Sorry. But right now, it's just kind of, we'll see it when it comes around or when this other satellite goes back around. And then to end, I wanted to leave y'all with some pictures of the auroras from the last few days, actually. This one and this one are both from the X2.3, because that one, while it was on the east limb, the halo did give us a glancing glow. And there is probably some corneal hole influence in here. That's probably why the glancing blow gave us that.
Where the photographs were taken?
Yes, both of these are from Alberta, Canada. Yeah, and it's so much. I could stand up here the whole time.
All right, we'll next go into the monthly space news, which obviously covers about a month. Okay, we'll have really just four major topics here. The Starship, of course, that happened exactly the next day after our last meeting, so it's kind of old news. I'll kind of skip through the highlights and talk more about what's coming, because that's so some of what's coming is going to be pretty soon. Missions to Venus and the Moon, and also some spacesuit stuff, because there's been news about spacesuits recently. So let's get right into this. All right. I'll just show you a series of pictures taken from the live beta display. If you watched it while it happened, you would see this, or it's available online. Obviously, it took off, and that was about a month ago. This is as it gets started, and it's a time machine. Now suddenly we're at the point where the booster is landing, and this, of course, is the signature move of this particular test. No one's ever done anything like this before, especially with something so big. So they did manage to land the booster right in the so-called chopsticks, the landing tower there. That, like I said, it pretty much amazed everybody. This is a view at the top after it's done landing. You can see the grid fins there. That's not what's supporting it. There's actually just some little pins sticking out the side. Those are the grid fins, which are aerodynamic surfaces for controlling the direction that it falls. But the actual pins are just kind of the little tiny things sticking out. And it's amazing. It's supporting all that weight. Now, meanwhile, of course, the second stage was still going up. And at this point, it was already coasting. You can tell that because on the right-hand side here, they're showing you which engines are lit. And no engines were lit at that point. There's 6 engines on the second stage. It's just coasting. So that red and various colors you see there, that's plasma. It's just because it's getting so hot. It goes up, it's kind of a ballistic trajectory in effect. It's just coasting, and it's working and coming back down. This is right before it landed. They hadn't actually quite turned the engines on. It looks like they were just lighting them up, and the display down here just hadn't updated yet. But this is only the very last minute. I mean, they really do just a few seconds before landing. They suddenly flip around and put it down, and they landed vertically in the ocean. And then it finally tipped over, and there was still some fuel, so it, it made a nice explosion and burning kind of effect there. So very dramatic. But at all this points out, of course, they had buoys sitting there. They landed exactly where they wanted to, and right in between the buoys that could take all these pictures. So what kind of results did they get from this? Well, the first thing is that compared to the last test, it did much better because they had a much better thermal protection system. They had done a couple of things. First of all, they put better tiles in. I guess they were thicker or better materials. But also underneath the tiles, they put in a whole new layer of ablative material, stuff that'll burn up. So even if the tile falls off, and sometimes tiles are going to fall off, they get knocked off or turbulence tears them away, whatever it is, in any case, they have a more protection underneath now, and that made a big difference. And also, in particular, last time, they managed to land pretty much where they wanted to, but some of the control fins were in pretty bad shape. They pretty much burned through, and it was amazing the control system was good enough that it landed anyway. But they put a lot more protection in for those, and they held up much better. They still have a ways to go. It did actually burn through in a few places, but it was really pretty good. Of course, the big thing was the so-called chopsticks. They just caught the booster, the thing comes down. Now, people kind of assume that the thing is coming really fast and it's just going to grab it and absorb a lot of the shock. Actually, it's going really, really slowly at that point. It's just under power, and so it really just has to gently grab it. But nonetheless, it works. But the booster is almost hovering, and that's something the Falcon 9 can't do. This is something that they have more power available, and they can do that. With the Falcon 9, when they land, those legs are absorbing all that shock. And in fact, they kind of crumple. So that actually, in a way, is part of a non-reusable part of the Falcon 9. And that was just one of those little areas where they wanted to address it and say, we want everything to be recoverable. But the reason they're doing this, catching the booster in midair, is you don't need to have landing legs at all. Now, obviously, later on, when you're going to land on the moon or Mars, you're going to have landing legs. And maybe even if you're doing, going somewhere else on Earth, you might need that. But for their routine flights, they want to have the thing go out and have the first stage come back to the original landing site. And basically, you take the complexity and the weight and just shift all that. Instead of being on the booster, it's just back on the facility. So that's why they call this stage 0. The launch tower is a significant piece of the overall system. It's not just a rocket, it's a whole system. There's another benefit to having this catch by the booster, have the booster being caught by the chopsticks, and that's that you got it right back where you want it because your refurbishing facilities are right there. And maybe, in the future, they won't need much refurbishing. They could even maybe do it on that launch pad. That's the dream. How long it takes to get there, we don't know. But that's the basic goal. Uh-oh. Is this still working? Oh, good. Okay. Yeah.
As he recovers his head.
Yeah. Yeah. I need a better control system like they have on that booster. Okay, so anyway, they need to do this because otherwise it takes a long time to get the booster back, bringing it back into port and then transporting it on land, wherever it has to go. That takes time. And that's going to matter because they want to launch a lot, and they have to launch a lot because the really long-range missions to Mars or even to the moon requires refueling in orbit, which means you got to have a lot of starships going up there carrying a load of fuel to refuel the one that's finally going on to the moon or Mars. So it really matters. It's, nobody really knows yet. They don't know the payloads. They don't really know how many flights it will take, but estimates range anywhere from 8 to 16, to get one deep space kind of a mission. So they need to be able to quickly refurbish these things, or they have to have a whole lot of them out there in transit between landing sites, and the original launch site. Another obvious conclusion, I worked in control systems for a while, and these people really understand how to control things. I mean, they've got a really complicated system here. They go from incredibly heavy to almost empty because the fuel goes away. They have different levels of gravity, different levels of control, either from the aerodynamics of when you're in the lower atmosphere compared to almost no air up near the top of the trajectory. There are so many variables there that they have to deal with, and they're doing an amazing job. So I think they're kind of the unsung heroes in this thing. They did have minor damage, like any test. It's not complete. So as I mentioned, there was some burn through. Some of those flaps did get a little bit burned up. They still have to work on improving the heat resistance there. Now there's a thing called a chine, which is really just a long fin, kind of a small fin that goes down the back of the booster down toward the bottom, typically to basically just help control airflow. Some of that, actually, the covering for that actually kind of ripped off in the process. And that happened apparently just on the way back as they were going subsonic, and apparently the shock waves associated with that transition tore it up. That was potentially disastrous because they have some valves in there which are needed to control the flows for the actual landing. So it all worked. No, the valves were unharmed, but they're going to work on that to make sure that doesn't happen again. There was some question about the engines on the booster. There may have been some damage. People thought they saw some pieces of stuff flying off near the end there. So it remains to be seen. You know, you do see a certain amount of smoke and debris. Sometimes that's just the thermal protection stuff burning off, and you can't quite tell. The other thing is, it turned out, we found out kind of inadvertently that they were pretty close to aborting the whole thing near the end. They thought basically it was because of a false alarm, which they concluded was really not a software error, but a parameter error. You know, there's maybe 1,000 criteria or some large number of criteria for is it okay to do this landing back at the launch site, and one of them wasn't really set right, and they came pretty close to violating that one. It would have been a false alarm, but then they would have had to abandon the mission. So test site flight 6, that's the next one. It might happen around November 18th, and part of the reason is, well, one, there were no major changes in the flight plan, so that the current license applies for that. And the second thing is there were no major abnormalities that happened in this. It was a good flight, so there's nothing that has to be investigated to hold up things. So they're going to be doing this next one pretty soon. Obviously, they're going to do what they can to address some of these minor damage issues and revise those parameters. A key part of this next test, most people think, is going to be relighting the second stage engines. Now, remember I said that in this test, the booster goes back to the landing site, the second stage goes on up, and it's just kind of coasting after it does its burn. It's just coasting and coming back down. Well, they have to test actually relighting the engines in space conditions. They know it works down lower because they've turned on the engines when you're back in the heavy atmosphere right before you hit the ocean. But they haven't done it in space. That's important because if they're going to have a next test, which will involve orbiting, and in particular orbiting and then transferring fuel from one vessel to another, they need to be able to then have good control over how to deorbit. And that says you have to be able to relight your engines. Nobody thinks that's necessarily a serious issue. That's why they haven't worked it so far. But it's still something that has to be proven. They haven't actually relit that engine in space yet. So that's a big part of this coming test. And of course, thermal protection. Some of that thermal protection changes are coming from moving the flat back a little further from the front. I'm not sure, that's already in the works. It's probably already done on some of the manufactured second stages. I'm not sure where that stands, but at some point that comes in. Okay, next thing though is going ahead to low Earth orbit. Once they've established they can relight the engines, it will be safe to start doing orbital tests, and they'll be able to. Nobody thinks that's going to be a serious problem because the speed they're going now is almost achieving orbital velocity anyway. That's why they purposely wanted to get it up there going as fast as possible without going into orbit, just for that reason. Next thing is there's a second launch tower being constructed down at Boca Chica. That has to be finished, tested out. It is stage 0. It has to work just like the other one. And the big thing coming up, not in the next immediate mission, but sometime in 2025, they really want to start doing the propellant transfer while in orbit. Now that means you have to have 2 of those up there. And they're talking about maybe launching them 3 or 4 weeks apart. But even doing that, you probably want to have both of those towers in operation. So I'm not sure how that's going to work. NASA was pushing very hard. They want a demonstration because this is a requirement for the moon mission, for Artemis 3, the human landing system. They have to be able, to have a ship actually get to the moon. And they can't do that without transferring propellant in orbit so they can then get there. There's another minor issue. They went with this concept of hot staging, where when you start at the second stage, the rockets are blasting out, and they do that while the first stage is still attached, and then they split. And that way there's no pause in the upward momentum. And that turned out to be a great thing. But it was kind of a hack. What they did was they just stuck an extra section in there to protect the booster. You don't have this problem with normal rockets because nobody cares about the booster, but they care about the booster. They want to reuse it. So they put in this hot staging ring. But the thing is, right now, they still don't really have all that much payload capacity, and it mattered. I mean, they decided they'd rather just get rid of that ring rather than trying to have it, come back with them. So they're just dropping it in the ocean, just like any other debris from any other rocket would have done. But at some point, they're going to merge that back in. there will be no more hot staging ring in the future at some point, and they have to test all that out. Okay, now, as I said, the big question is really, what is the payload of this thing? It doesn't appear they have that much extra capacity right now, but there's a lot of improvements coming along the way that are going to change that. So that means more testing. In particular, the next versions of Starship, at some point, I'm not sure exactly which version, it's not this test, they will be taller, you know, an extra section, I don't know, 10 or 20 feet, whatever that is. Basically to hold more propellant and get a little extra payload that way. The second thing is upgrading. The big change will be the engine version. Raptor 2 is the name of the current engine. The Raptor 3 has a whole lot more power and it weighs a whole lot less. And so that's going to make, you know, that's what they really need to achieve, even certainly to achieve their 100 tons to payload kind of a goal, and probably more than that. There's some other issues that they've never really quite resolved. In one of the earlier tests, they did show opening a payload door. And it wasn't that convincing that it was really working that well, but it wasn't really that important at that stage anyway, so they just kind of let it slide. At some point, they need to address that, partially because SpaceX really wants to get back to launching Starlink satellites. They want to do that now, you know, with this new rocket because they have such bigger capacity. In particular, they can launch the version 2 Starlink satellites, which are a lot bigger and heavier than the existing ones. So they have a big economic incentive to get that going as soon as possible. There's a special dispenser. It's a payload thing. They call it the PEZ dispenser because it just kind of shoots the things out off the side. And they need to get that going, independent of the, you know, the goals for the Artemis mission. So they really have two different things there. There's their commercial interest, which is they need to get, you know, things launched as soon as they possibly can, either for revenue or for their own purposes for Starlink. And the other thing is meeting the needs for the Artemis lunar. And at some point, they're going to have to try catching the upper stage of the ship. Most people think that's a lot harder. There's tiles that are going to be damaged, that sort of thing. It's not quite as obvious how they're going to do that. Either they're going to have to, you know, work out some more details, or maybe put legs on a thing and land. I mean, the earliest versions of Starship, which was just the second stage, when they were calling it a hopper, they had legs. You know, so they've certainly done it before. They know how to do legs. At some point, reflying a booster. They haven't done that yet. At some point, reflying stage 2. They haven't done that yet. At some point, launching from Florida. They have facilities going up there. It's not as far along, but they do want to get that going. It will be needed fairly soon. If you're going to start doing a bunch of refueling missions, you want to have as many launch sites as you possibly can. And some of that's risk avoidance too. I mean, if anything happens to one of those towers, you're pretty vulnerable right now. Yeah.
Elaborate on reflying.
Well, they're talking, they caught even this one, they caught the booster when it came back. Well, the next step would be, well, refurbish it is whatever you need to do and then launch it again. Like they're doing with Falcon 9, they're getting up to over 20 reuses with some of these now. They want to do the same thing with this.
They haven't done this with Starship.
Oh, no. No, they probably isn't in good enough shape, yes. I mean, this will take some time. But they really need that, but once they have that, the economics are so favorable. It costs so much more to build a rocket than it does to fuel it that the economics really drive you to go toward that. That's why the Falcon 9 has been so successful, and they need to do the same with Starship.
Right?
Yeah.
There's one other thing about, correct me if I'm wrong, the larger the dimensions of the rocket, the more economically viable it is. Big rockets cost less per pound or per pound of payload than a small rocket.
Could be.
I read that somewhere.
I mean, it might just be the cost of the metal itself. Yeah. I mean, the only thing that goes against that is that things have to be built more sturdily when you got it really, really wide too. So, yeah.
I don't understand the fueling and all that. What I don't understand is we didn't refuel on going to the moon to begin with.
Yeah.
So why are we having to do it now?
Yeah, I don't really have a good answer for that, actually. I mean, and neither does NASA, for that matter. I mean, the SLS couldn't do it either. That's part of the reason they had to have this whole orbital gateway thing, is they couldn't do it either.
Economics that the moon missions were incredibly expensive.
Of course.
Yeah.
Yeah.
And doing it that way, it would just be.
No, that's true. The emphasis is this is supposed to be reusable, and you do pay a price for reusability because you have to carry more fuel so you can land back, back where you came from. That takes extra fuel.
It's just interesting to say 8
Yeah.
to 16 times you're going to have to
Yeah.
move fuel just
Yeah.
to get to the moon. We didn't even do that.
Yeah. But there's a question of what does it cost? Oh, yeah.
Well, that was one of the options.
The bookkeeping on that. Just
Oh, yeah.
to see how that
Well,
works.
and everybody thinks that's going to work out much in their favor because it costs a lot to build something. The actual fuel cost isn't that much when you get down to it. And as long as you can make everything reusable and quickly turn it around, you just don't need anywhere near the number of boosters. I mean, the good example is the Falcon 9 with its booster. There's a big difference in payload. If you expend the whole thing, you use every ounce of fuel to get you into orbit, which they do sometimes. That cuts way back. You can go up to like say 37 tons or something, to low Earth orbit or maybe even higher, and you're down in the 20s or something, when you have full reusability. The worst case is returning to the launch site. The other case is returning to the ocean because you launch from Florida, going in the direction of the rotation of the Earth. You get some boost from that, and then you land on the ocean. That's a lot better than fighting essentially and going all the way back to the landing site.
Sure. Yeah.
So.
But the flip side of that, of course, is that if you use the rocket with the one-time use only, it's true, you get 37 tons on board. But, and it's like, oh, well, this other way you can do it useful, then you only get 22 tons up to that orbit. It's like, oh, well, that's a penalty. Yeah, well, the big penalty comes from the fact that that first one goes up into orbit, and that's it, it's gone.
Right.
No use. This the other one, second version, it goes up, but it comes back. And they only pay for that rocket. Build and manufacture that rocket one time. First option, throw it away.
It's also interesting. I was digging a little bit into the environmental impact of all this, even, and it turns out that the environmental costs, in terms of if you counting for CO2 or all kinds of waste from mines and their metals and so on, it turns out that it's much more expensive, not only economically but from even an environmental standpoint, to throw away a rocket than it is to keep reusing it. So because you only pay it once, if you can amortize that payment over 10 or 20 launches, it says that the cost per launch, the cost per ton to getting it up to orbit is just so much less that it really works out. And I said they've kind of proven that already with the Falcon 9. This is just taking it to a much bigger extreme with a much bigger vessel. Okay, so reflying, launch in Florida. Okay, long duration mission. That's still an open question because even just while you're waiting for the ships to come up for your refueling mission, you've got to keep these coolants cold, and the fuel's cold. I mean, you got liquid oxygen and liquid methane. The easy approach is we just let some boil off, and as it boils, that carries heat away, and then that's what happened if you have a Dewar flask or something on Earth with liquid nitrogen or oxygen in it. That's how you keep it cool. It just basically is an insulated container, and it's not completely sealed, so some of it just vaporizes. But obviously, that says you're losing material over time. If you're going to have to wait around 3 or 4 months or something between launches, you might lose a substantial portion, and if you lose too much, you're never going to fill the thing up. So. 3 or 4 weeks, probably it's not too bad, but.
And that's 16 thermal cycles a day. 93 orbits.
Well, yeah, that's right. You have to worry about that. And then.
Plus 300 Fahrenheit down to minus 250.
Yeah.
So that's really hard.
Yeah. Well, that's more heat load to worry about. You end up having to vaporize more just to make up for that. So, yeah, it turned out, for a long time, just because of the politics, no one was allowed to talk about orbiting fuel depots and that sort of thing. But now they are, and even United Launch Alliance, they're proposing making an orbital refueling system using the Vulcan. But they said, well, okay, and they're doing the logical thing. They're saying, well, okay, let's put shades around it. Basically, you make a big metal cone that's a shade to keep the sun from hitting it. Right there, that cuts out a lot of evaporation, cooling evaporation is needed. And the second thing is that's not enough. The next thing would be go ahead and put refrigeration equipment in there. It's cryogenic fuels. Well, we can do it on Earth. You can do it in space just as well. It's a little harder, but you can certainly do it. But it takes some energy to do that. It takes a lot of extra weight. So, there's a balance there of how much of that you want to do. But that's the kind of stuff they have to work out, because even in the case of going to the moon, it's quite possible that, because of delays that happen now and then, you could have a ship sitting up there for, they're saying, 6 months sometimes, just waiting for the astronauts to show up. All it takes is one delay and, things get behind. And you need to start accounting for that. So at some point, they're probably going to be doing, installing some equipment, to do some refrigeration, maybe some kind of sunshade. It's going to be a big sunshade in the case of a starship.
Sunshade is partially colored with solar panels.
Well, yeah, you might as well. Right, to run the generators.
Exactly.
Yeah. Or no, I'm sorry, to run the compressors that are needed. Yeah.
Now we know how to make.
Yeah. Yeah, but ultimately, the problem is you still have to radiate it into space, so you need big radiators as well. And then, it's much easier on Earth where you have convection and conduction to help you out. You don't have that in space. All you've got is radiation, so it's a lot tougher problem.
That makes it very difficult.
Yeah. So anyway, that's probably why they haven't addressed it yet. It wouldn't surprise me if there's people are thinking about it, because it is one of those things that's obviously coming. And that's a problem you just didn't have when you're using kerosene as fuel, like the Falcon 9 does. You just don't have that kind of a problem. If you're using liquid oxygen, liquid hydrogen, yeah, then you have the same problem. Okay, then of course, actually, part of the contract that SpaceX has is to do an uncrewed lunar landing, meaning they have to go all the way and land, prove they can land on the moon. And that's not trivial either. I mean, it's a long way to go. It may be hard to find a level enough surface. How level does it have to be before the whole thing tips over? There's a lot of questions there that really have to be answered. So they really have a lot to do. But the usual game in contracting, and it's not just government. I mean, I've seen other organizations do this, but you always hope that the other guy in the other division is going to be the one who makes the schedule slip. And so nobody wants to say, "Oh, I'm going to screw up the whole schedule." They don't say that any earlier than they have to.
They need. I just realized this is the high priority mission for intuitive machines. They ship a little bulldozers somewhere, and then they spend 3 months slowly bulldozing a flat place for Artemis to land.
Possibility.
That
Yeah.
would be, I think, a very smart use of the intuitive machines, little bulldozers.
Could be.
Preparing an area.
Yep.
Because it would be worth spending the money, because it's a big rocket coming down afterwards.
Yeah.
You don't want it to tip over.
Yeah. I have to look. I haven't looked much beyond this upcoming mission. I'll have to see what their future ones are. That's a good point. Okay, so let's see. For some reason I'm not getting it. Okay, so the next step here is a mission to Venus. Now, some of you probably know what this mission is, so say those of you who do, don't answer this question. But for people who don't, when do you think I'm talking about, and how much do you think it's costing? Of course, I guess I'm asking.
$1.
I can always count on you for the the best possible answer.
$500 million, and yeah, in 4 years.
Okay, actually, the answer is next month,
Oh,
and the answer is $10 million, by the way. So, and this is going to Venus. Now, it's not big. That's one thing. Obviously, this is not to scale. That thing is not as big as. Okay. They have a goal. They're going to look for, and this is Rocket Lab. It's a private mission. That's the other thing. This is the first mission to another planet run completely as a private mission. And it's on Rocket Lab, which only makes small launchers. I mean, the rockets are pretty small, really. So this is kind of interesting. Anyway, why are they doing this? Well, they want to look for organic materials in the cloud droplets, supporting traces for life. And that actually isn't as crazy as it sounds. I mean, there was partially because of the fact that, okay, on the surface of Venus, it's ridiculous. It's just hot, high pressure, sulfuric acid is a mess. But if you're up in the clouds, there are places, you go up high enough, it's very similar conditions to Earth in terms of temperature anyway. You still got that sulfuric acid, but at least you have, temperature is reasonable. And people have theorized that at some point in the past, because you had oceans on Venus, there could have been life that evolved there, and maybe it survived up in the clouds because you have a heavy layer of clouds. In some areas, it's cool enough. Life could have gone on, or could have evolved. There in any case. So they want to go find that out, and Rocket Lab kind of wanted also a little bit of PR to highlight their spacecraft ability. You know, instead of throwing a Tesla up, they decided to do something, you know, that it might actually provide some scientific value. And so that's what they're doing. It's a private mission to another planet. No, actually, they will not detect phosphine, but they will detect, you know, they will detect a lot of other things. And I'll get to that in a minute. But yeah, actually, phosphine specifically, they won't even recognize. But why Venus? Okay, as I said, once upon a time, it had oceans and much more moderate temperatures. They think it probably had kind of a runaway greenhouse effect. Nobody really can know because it's just so hard to tell what's going on there. Anyway, as I said, the phosphine detection, that turned out was probably a false alarm. But the thing about phosphine is, even on Earth anyway, most of that is generated only through biological processes. I mean, okay, a chemical plant can make it too, but for it to occur naturally, it's typically biological in origin. And that's why people got excited. There was a big fuss over this some years ago. It turned out like it was probably a false alarm, but you know, people aren't 100% sure. And so this is a way to find out more. So their goal is to get to about 30 miles altitude. That's where the conditions are probably as close to Earth. You know, reasonable temperatures, reasonable pressures.
30 mile out.
Yeah.
They're not going to fly.
Well, they're going to fly down through it and then just crash into Venus eventually. I'll get to that. Okay. So first of all, how do you get there? I mean, we're talking about an electron rocket. I've done the lower left corner of the slide here. I'm reminding people, 59 feet high, that's nothing compared to the 400 feet of Starship, for instance. It only, for a low Earth orbit, it only puts up 660 pounds, and obviously it could be a lot less than that for going, you know, to Venus. And how are they going to do that? Well, they're going to do the same thing they did on their last lunar mission. They have already done one lunar mission, and they're doing actually exactly the same thing that we talked about with the last Indian lunar mission. They did exactly the same thing. Basically, you get up to low Earth orbit, and that's shown in this diagram here. And you know, once you're there, what you start doing is when you're typically your orbits are somewhat elliptical. They're not really perfect circles, but usually when you're closest into Earth, that's when you're going the fastest. You know, if you think about the way the mechanics work out, you know, when you come in close, you're going really, really fast, and then you go really, really slow in this big loop, and you come back around. And it's most efficient. It's the Oberth effect that we've talked about before. If you're going to apply thrust to go faster, you want to do that at the point where you're going fastest. And that's right there when you're closest to Earth. And so each time they make a pass around Earth, they do multiple orbits. You know, they blast out some thrust, and they make orbits that are bigger and bigger, and they're shown here. Each one goes out farther and farther from Earth. And at some point, you decide you're far enough, and you do a little extra thrust, and you head off toward the moon. Then they get a gravity assist from the moon. They let the moon pull them around and shoot them off toward Venus. So they're doing the same thing here that they did on this previous mission that they'd done before, called Capstone. Some of you may remember that one. That was the one where they were going to try out the orbit, the orbital gateway, which is the NASA lunar or, you know, space station for the moon. That one's going to be in a kind of an unusual orbit, and they really wanted to prove that you could actually be in that orbit without consuming too much fuel to stay in that orbit. So they did a really small satellite, and they actually used this, and they did exactly the same thing. This diagram was actually taken from their literature on that previous mission, but the new one is pretty much the same, except what happens out here, you come over to the moon, and instead of them going into a lunar orbit, they go shooting off, you know, they go shooting off to Venus, so it's a little bit different. Anyway, what happens is they do that, they shoot off to Venus. Now, when they finally get there, Photon is the name of their spacecraft. That's just the name of the thing. It actually only weighs about 37 pounds, the spacecraft itself. And it's got a small probe, which is 45 pounds, that's attached to it. And it's 16 inches across. So we're talking about something that's not terribly big. You know, you can pretty easily pick it up. But that's what they're sending. So obviously, that's pretty limited. You can't send, you know, this is not as sophisticated a mission as a lot of the big NASA projects that do cost a lot more. This is what can you do for a very small amount of money, and this is what they can do. So basically, the thing's in kind of a cone shape. So obviously, as it goes down through the atmosphere, it's shaped so that it'll stabilize with the going down in the downward direction as shown on that diagram. There's a pressure sphere, a pressure vessel that contains all this stuff because you're going to get higher and higher pressure. But the key instrument is this little one that's shooting off the left-hand side here. That's a laser. And what this thing does is it shoots a laser into the cloud, basically the particles, the droplets that are in the air, and it looks at the diffusion. It senses the diffusion. And from that, they apparently can draw all kinds of conclusions. I mean, I wasn't actually familiar with this. It's called a nephelometer. You know, I had to look that one up because I hadn't run into that one before. But anyway, it's just a particular technique, and it's used for various things on Earth as well. This is not the first time such a thing has been used. But they can draw conclusions about the materials, apparently, just by the reflection and diffraction of the light. And then, in particular, because of the frequency of the laser, some organic materials will actually glow. You know, and that's not the phosphine that, you know, some people might want to find. But, you know, anyway, they can do a lot. They can figure out some of the composition of the atmosphere from that. So, and they're going to do this. They only have about 3 to 5 minutes. They're going to be coming down toward Venus at 37 miles. You know, that's where the action starts to happen. They really start paying attention. They're transmitting data back. And as it falls down to about 28 miles, they're sending as much data as they can. It's a pretty low bandwidth. It's like 125 bytes per hour or something. It's pretty small, so they have to really compress that signal. But that's one reason, you know, they're not doing a whole lot of instruments. They probably didn't have the bandwidth to send back much data anyway. But they'll have enough. They think they can actually get quite a bit out of this. What's other interesting is, okay, Peter Beck, who is the CEO of Rocket Lab, he says this is basically a nights and weekends project. Now, can you imagine working at a place where, where in your nights and weekends, oh, by the way, we're building a probe, we're going to Venus. You know, it's a little different. Now, that's not completely fair because he's talking about his own people. Now, actually, MIT had a big role in this. They have, you know, grad students. You know, they're really cheap. But they're cheap and smart. I mean, especially at MIT. So that and students, they probably had, you know, 30 people involved at one time or another, all part-time. But, you know, you had a fairly large number of people working on this. So they got some outside help. It wasn't just all of them. Rocket Lab is pretty much providing the means to get there, you know, which nobody else would have provided. So they're getting that. And actually, Ames Research Center of NASA did help out some. They provided the thermal protection, which is a key thing for this, because, you know, as we said, Venus is a very, very hot and unpleasant sort of place. So they needed all the guidance they could get, and they got some help out of the Ames Research Center for that. Anyway, the cost is probably less than $10 million. They don't have an actual thing, but that's, you know, by space travel standards, that's so minuscule. That's less than the cost of, you know, of any rocket launch, even normal rocket launch. So. Pretty impressive. Okay, moving on. Now we're doing lunar mission. This is a little closer to home. It seems close now, doesn't it? Think about that. This is Intuitive Machines. There had been a Lunar Mission 1. Remember, that's the one that it landed there, but it tipped over. And in fact, there was this picture I showed last time of the CEO with a little plastic Lego model showing A and B. This is what it looked like, and, you know, demonstrating that it can tip over. So, and you can see why, because it's kind of a tall thing. It's actually 13 feet tall. And it's got landing legs, but, you know, you can imagine if one of the legs crumples on landing, or if you just land on too inclined to the surface, you could tip over pretty easily. So this is mission 2. It's all part of the CLIPS program, which is Commercial Lunar Payload Services that NASA funds, and they do a lot of these kind of missions where they're pretty much paying for the transportation to get there, and then in this case, they also specified some of the things that are being done. So. Some of the things that are being done are financed by NASA. Some of them are not. It's a private mission. They're, you know, the company is free to sell, you know, whatever they want to do, and they do that. They're landing close to the South Pole of the moon, called the Shackleton Crater. It's actually an area near the Shackleton Crater. It uses the Nova C lander, which is the same one as their last mission. You know, it's been modified. In particular, they made the landing legs stronger. They figured they need to do that. They also said that unlike last time, they're going to remember to flip the switch back on, which enables their laser rangefinder. That was the biggest single problem they had last time, was they crashed. They landed too fast because their rangefinder wasn't turned on. There was a manual override to protect people's eyes while it was back in the facilities where it was built. And yeah, I mean, I don't know how many people remember that, but they were pretty embarrassed about that. That basically, they would have done better if they even just had not turned off, or somebody had remembered in their procedures to flip the switch to turn back on the laser. So I got that anyway. This thing has a payload of about 286 pounds. It's not tiny. You know, it's the size of they call it a Volkswagen Beetle. You know, 4,200 pounds. That's with fuel. That's the so-called wet mass. It's got solar panels, a couple hundred watts of that. And it is methane and oxygen fed, which is different than most of these landers have had. Usually because it's easy to do the hypergolic propellants, you can pretty much start them anytime. This is a little more iffy, so they were taking a bit of a chance there. We had talked about this actually quite a bit in one of the previous news segments, so you can look back at that if you want some information. Now, the primary payload of this, called Prime 1, this is the NASA mission piece of it, basically has a drill. They're looking for water ice. And they don't expect to find much on the surface. However, they're going to go down maybe a meter, 3 feet or so, and they're going to drill for it. So, and that is actually the drill I highlighted there with that little yellow arrow. And there it is. That's the drill. Okay, so the drill there, they're going to drill down a foot. What they'll do is they'll bring the samples back up, and then they have a mass spectrometer to do some analysis of it, which they can do right there. So this thing doesn't move. This is just a lander, but they know they're going to, so if they get lucky, they might find something there. But there's, it does depend to a certain extent on luck, but at least they're making a start on this. But wait, there's more. Inside that lunar lander, there's also a radiation monitor, and also Nokia is providing a 4G cellular network. Why 5G? I don't know, but 4G, because really you want to be able to, if you're going to start putting a lot of stuff on the moon, they need to communicate. And apparently even the 4G level communications are much faster, the data transfer, much faster than they're getting with their current systems. And the other one is that they have a hopper. Now the hoppers doesn't mean with like a pogo stick. This is actually with rockets. They're little ones. You can see them underneath there. That big thing is, I think, a sensor, but the little rockets are down under here, engines. And their goal is to find the ice in the permanently shadowed regions. People say that any water on the surface has probably been boiled off by the sun long ago, but there's a lot of shadowed craters, especially near the South Pole, because the sun is coming in at such an angle. Huge areas of shade where it's really, really cold, and ice could easily accumulate there. In fact, some of the ice that actually evaporates from the sun might have condensed inside of it. They think that mechanism could be applicable. So they're looking for that, and they have their own neutron spectrometer, which will allow them to look for hydrogen, which is a key indicator of water. And so it will jump in. It can go pretty far. Actually, it can carry a couple of pounds and go 1.5 miles. And so they're saying, well, they'll jump into the Shackleton crater. They'll, if they find a lava tube nearby, they'll try going into it. Whatever they find, they will try to explore as best they can. So it can get places that a normal rover couldn't get. And the thing is, you'll get places that until you land, you're not going to have a chance to look for these small holes and small craters and that sort of thing. This one does use hydrazine, a hypergolic thing. They're turning it on and off really quickly. They really need that. And it's about 30 inches tall. It's not tiny, so it's, shorter than most of us. But, it's a real thing. Interesting to see how it works. But wait, there's more. We're not done yet. There's a rover in there too. This one actually, that one might be on the critical path. There was some concern that maybe that one wasn't going to be ready yet. But it's a mobile autonomous prospecting platform. That's what it's called. Now that's kind of a generic picture there on the right-hand side. The actual one that will be going there probably will look somewhat different. For instance, it has a roof, if nothing else. But that's kind of the generic thing with various fixtures could be attached to it. So I'm sure what's actually going to look somewhat different than that. That's just their marketing literature. But what they're going to do, they can do some mapping, very detailed mapping. They're going to take samples. They're going to have a little digging thing of some sort. They can take 3D pictures. What's interesting is they're using a modified version of something out of Xbox. I guess it was cheap. And they will be part of the cellular network test. They'll go at least a mile away. This thing will go pretty far, apparently. And it weighs about 22 pounds. It's 18 inches long. Now, you probably also heard about this, that as part of the Artemis program, the Artemis Accords, the whole idea is that, no country can claim, or even probably a company, can really claim a piece of the moon or any planetary body. However, you can extract the resources. Well, not everybody agrees with that, but people who signed up for the Artemis Accords do agree with that. And this is kind of an attempt to just do a demonstration of a norm, try to establish a norm that it's going to be normal to extract resources and sell them. And so NASA's going to buy, a pile of regolith for $1. It's not clear how they're going to take delivery. I guess that'll have to be a future one of these, something like that. But it's really more just establishing the principle. But wait, there's more. Inside that rover, we're talking about something that was inside the lander. Well, there's actually, on the roof of this lander, there's a little tiny garage, and there's There's an astro ant. One astro ant is going. What is that? Well, it's a miniature rover. It's got 4 wheels. It has very strong magnetic wheels. So it can, the idea is it can go up and around and so on. These things are the size of a matchbox. There's 16 in that picture there, but only one of them is actually going on this. What?
They bring a bucket along.
A what?
Fueling station.
Well, actually, it's rechargeable. In this little garage, apparently, it can be recharged.
So
But-
did the MIT build those? I see it says MIT.
Yeah, and well, yeah. The MIT Media Lab has always been an interesting place. They do actually a lot of hardware stuff like wearable, computers and all that kind of stuff. So, yeah, and yeah, that was just taken at their site apparently, just the one. But what it's going to do it's really a prototype just to demonstrate the principle. They're going to go over the roof and just measure temperatures. Now, that may not be that urgent of a need. You'd like to know there's a hot spot, but they're kind of demonstrating the point that their future vision is you're going to have robotic swarms that'll be available. Doing inspections and diagnostics, that can be on any spacecraft, on the moon or even in space. When you're looking, say, for a micrometeorite hole and you've got a small pressure leak, you can't really have sensors, every inch to try to figure out where things are to locate them. But you can have a swarm of robots kind of going all over and looking really, really carefully with different sensors, outfitted with different sensors. And so that's their vision. I mean, of course, it might scare you, those who remember the old Stargate series with the replicators. Yeah, this is the early, okay, this is the earliest stages. Don't worry about that. But it's actually kind of addressing a real need. Is in general, you need some way to be able to inspect, when problems occur, and this gives you one. Now they're saying, taking a little step further, at some point they could be doing assembly and servicing as well. Obviously, these don't have that capability, but it's a start. So they're just sending one to test it out cheaply. And wait, there's more. Now this is taking a step back. The rocket that's taking this thing to the moon, it has plenty of spare capacity. The last time they did this, they actually returned to launch site, which takes more fuel. But nonetheless, they did that. They've actually got several secondary payloads on this thing. One is a lunar communication satellite, which I think is partially relaying some of the signals back for this mission. Another one's a separate thing called the Lunar Trailblazer. And this is a lunar orbiter. This is actually a NASA project as well. It is going to do some detection and mapping of water and minerals on the lunar surface. They have some kind of instruments for doing that, and also looking for future landing spots. So, and it's pretty good size. This is 460 pounds. It's not a little CubeSat kind of a thing. I mean, this is a significant thing. And that's not all. There's also a spacecraft called Odin that's going to go off and survey an asteroid, do a little prospecting on an asteroid. That's purely a private mission. Astroforge is a company. Their business is they see an opportunity for extracting platinum group metals from near-Earth asteroids. They're saying it's actually not that expensive to get to a near-Earth asteroid. It's actually not really necessarily much worse than going to the moon. You just have, if you pick one carefully. So they're looking for those, and they picked one that they think has a pretty high probability of having recoverable metal in it, and they've kept it a secret. They're not revealing yet which one it is. They're afraid of competition, I guess. But as a result, they are the first commercial entity that has now gotten a deep space license, and that's from the FCC for communications purposes. But so there's a lot of these kind of private mission kind of things that are creeping in more and more, and and getting licenses to show for it. It's kind of interesting. This thing weighs about 220 pounds. They had kind of a checkered history. They had trouble with their first. They were trying to demonstrate how they were going to do this refining of metals in space, and they had some kind of problem with that craft. And then they built another one, and that one, they outsourced some of the construction of it to some company that it basically had big cracks and wasn't working either. They finally just broke down and built their own. So they're kind of behind their original schedule, but this is now all their own stuff. Could be interesting to see how this goes. But they see a market for bringing back small quantities of high-value metal actually back to Earth. So that's their business. Okay, spacesuits. You've got 3 of them here as sort of sample. That's a Russian, Chinese, and American at various stages. This is being driven by the race to the moon right now. We need lunar spacesuits, and this was a picture put out by NASA. They were sponsoring, back when they were sponsoring some competition for getting people to bid on building spacesuits for them. Now, the lunar spacesuits, they're different than what you need for the space station, or really microgravity in general. It could be, something besides the space station, like repairing the Hubble Space Telescope, those kind of things. The biggest difference is when you're on the moon, you use your legs. You don't really use your legs that much. When you're on, if you're out, you're doing a spacewalk around the space station, they're just kind of along for the ride. They're not really doing much because they don't need the strength. You with your arms, you can move yourself as fast as you need to, and you need to walk. You need to be able to bend. You don't really need that so much in the space station on the outside of it. We're talking about extravehicular activity here, going on the outside. But you need flexibility. You need balance. I mean, if the thing is weighted too heavily to the back, you'll just flop over and you'll be like a turtle and not able to get back up. You don't want that. Sitting in a vehicle, if you've got a lunar rover, you need to be able to sit in the seat. You'd rather not have to stand the whole way. And the other thing is a tethered life support, like SpaceX did with that Polaris mission. It's not really an option. If you're doing maintenance of the space station, you're supposed to be close to the space station to do that work. But if you're on the moon, your whole point is to get away from the spacecraft and find stuff. So it's a completely opposite goal. So you need to be able to walk around with a self-contained apparatus. The other biggest difference is it's a nasty environment. There's a lot of fine dust. It's extremely, extremely sharp. It hasn't been eroded away by years of wind and moisture like it is on Earth. It's very, very sharp. It's really horrible for your lungs. It's horrible for all the equipment. And of course, you have rocks if you're walking. You need more serious boots. You need more rugged fabric and everything else. Static electricity is a huge issue. It attracts the dust. And so people are working out schemes for doing that. But it has to be considered. And not only on the suit itself, but for that matter, cleaning it so you can go back into the spacecraft. Now, a lot of the approaches, apparently, they're just going to come into the back of the spacesuit and maybe leave it, kind of outside. That's what a lot of people are thinking about these days. So what NASA has done with the extra vehicular activity, the EVA spacesuits in the past, looked like that. The thing about it is they're using them on the space station. They were last updated in 1998. And now they've been refurbishing them and, so on. But they're basically pretty old designs. Some of these things are 40 years old, which is older than a lot of the astronauts that are using them. It's like Goodwill or something. The typical spec seems to be having 8 hours of life support, and then maybe in this case, a 30 minutes backup. So if something went wrong with your primary system, you've got another 30 minutes. That seems to be a pretty typical spec for these things. But the spacesuits they are failing. People have been getting water in their helmets. They've had people almost drown while they're on a spacewalk, and that's a very serious concern. And the last I saw a figure on this, back in 2022, they had about 18 spacesuits that were usable. And they're somewhat modular so that at least they can adjust for the sizes of, men versus women to some extent. They wish they had a better variety for that. But really, there had been variety of studies and so on put out, and no products really came out of it. A lot of money has actually been spent trying to develop spacesuits, and it hasn't succeeded. And NASA got pretty worried back in 2022. They contracted finally 2 vendors, kind of like the Clips kind of a contract where, they're contracting for the service. It's literally going to be a rental service. It's like renting a tuxedo. You could rent a spacesuit, same kind of a thing. And so for lunar missions, they picked Axiom to build the thing. That's a company just south of, you've probably seen the old Fry's that had the space station mock-up in it. It was kind of a perfect location for them to go to. And then Collins Aerospace is building the ones for ISS, meaning the microgravity kind of spacesuits. And they were one of the traditional builders of these suits. Everybody figured, well, they'll nail it. But of course, they were the ones who didn't really quite succeed in the past. So anyway, NASA also got a little bit worried that, if one of these might fail. And so they also just said that, well, they'll fund cross applications. If you can take whatever you're working on and show that it could be used for the other application, lunar versus space station, they'll fund that additionally as well. So the results so far, it's mock-ups. They don't have the actual suits yet, but Axiom has a spacesuit. The XEMU is actually NASA terminology for extra, what does it stand for? Extravehicular Mobility Unit. And then Axiom threw an A in front of it. I don't know if people are going to say Axiemu or what they're going to say. A mock-up of this was shown this year, and Prada worked with them. And that's not an obvious connection. But what they said was, obviously, they weren't really doing it for fashion and appearance. It was more, they actually do have expertise in fabrics and garment design and that sort of thing. So they brought them in, and they said it actually really helped, especially for the outer layer. I think most of the insides there's a lot of engineering going on that doesn't necessarily involve Prada. But Prada, they said they had, like, at some point, maybe 30 people working on it. not full-time necessarily, but there were a lot of people, and they were really interested. This is kind of cool for them. Very different than, equipping models to walk down a runway. So capabilities, they're just basically saying it's better in all ways, including fitting. And now they're going to support between the 1st and 99th percentile of sizes for men and women, doing the same kind of support 8 hours. So what's the status? Well, they're still in the critical design review process. That's just part of the overall process for building things at NASA or lots of other places. They haven't frozen the design yet, so they certainly haven't started manufacturing, but they've been building these prototypes, and so they have people come out and show what it would look like. They say they'll be ready for Artemis 3 landing, even if it happens as early as 2026, which at this point nobody actually believes. But anyway, it's they'll be ready for it, and they claim they will be adoptable for walks in low Earth orbit as well, the ISS spacewalks. And that's a good thing, is because Collins Aerospace dropped out. They basically gave up. They said, we can't do this. So actually, this is the only show in town right now. And that's a little risky because, as it turns out, they're in financial trouble. They've fallen behind on key payments to they have several other businesses going on, by the way. So, one of them is building space station stuff, and they're behind on paying the people that are actually bending the metal, which is a European Alice company. And also, the other business is managing crewed, typically private missions. They handle all the mission booking and so on, and the running of it, for that matter. They have their own control center. But what's happened is they botched it, and there's a new CEO now. Yeah, they had to blame somebody, so they blamed the guy, one of the two co-founders. So they got rid of this guy. They've had trouble meeting payroll. There's some layoffs going on, and there's a lot of speculation in the press. So I'm only repeating speculation here. I don't take this as any kind of gospel thing. Some people said that they were pricing those private missions they were doing. They were losing a lot of money on them. They were actually doing this kind of a loss leader. And that works if you're a big company and you have other sources of income. But when you don't have a lot of other sources of income and you're a startup, that's not necessarily a good approach. The other thing related to that is they probably overhired. If you get, you assume you're going to keep on getting investors, you can do that for a while. But at some point, you got to actually have the income coming in to pay for the people you're hiring. And they got way, way ahead of themselves.
Yeah, they did.
Yeah.
They had very big ideas about what they were going to do with food on their mission. They hired 2 food scientists, and then laid them off.
Oh, yeah. So yeah, they're going to have to just to get back in balance. They're going to have to. The thing is, because they have these 3 businesses, and actually the only one that's actually bringing in cash flow right now without losing money on it is the spacesuit business. So that one. Let's hope that at least that survives. I hope the space station and everything else survives as well. Forbes was quoting some sources saying that the previous CEO basically they didn't really run Axiom like it was a startup and with limited resources, and that's a common failing. I mean, this happens a lot. People come from big companies or government, and they're not used to that environment where they could actually fail completely if they just don't have the cash to cover their expenses, and they're not used to it. Okay. The Chinese, of course, are active. They have a space station, so you can guess that, yes, they have spacesuits. And they're a lot newer than ours because their space station is a lot newer. Early on, they were using Russian suits. Orlan is the name of the spacesuit line that Russia has. But they did their own. They last updated them in 2021. They're good for about 8 hours also. They weigh about 260 pounds, which is right along the lines of ours. They actually have specs on the number of uses, and they're saying 15, which matches actually what the Russians do. So they've kind of followed the Russian specs on this. I never really thought about how many times you get it, but we're probably over that with spacesuits on the space station. And so however, that was for use on their space station, microgravity conditions. For lunar uses, they didn't have anything, so they're still working on it. They had a big press conference to announce their design, not the actual product, but the design. And they did a demo. They had somebody come out dressed up in their spacesuit, kind of a prototype. And in particular, they were demonstrating that they could bend, and they could do all the kind of things you'd really like to do on the moon. They still are serious about landing astronauts on the moon by 2030. And they're just, this is, of course, progressing along with that. There's no reason to believe they won't achieve either the spacesuits or the 2030 goal, for that matter. They're emphasizing being lightweight and flexible, much more so than the ones that are on a space station. The usual things, handling the extremes and the radiation and dust. I didn't see a spec for this particular suit beyond 6 hours. That's what they're saying they need for their activities, but chances are pretty good it's probably going to match all the others. That leaves the Russians, the other major space power here. They've been using those forever. I mean, they go back to the Mir space station, or even, I guess, before that. But their latest update was in 2017, and they claim 9 hours. They said 7 hours of primary life support. Maybe that means 2 hours of backup. I'm not quite sure. It weighs about 240 pounds, similar kind of weight to all the rest of them. They also specify the 15 EVAs over 4 years. And they're, you don't necessarily think of them as being technology leaders in a lot of things, but they've got a computer built into this thing to analyze malfunctions. They can show a contingency plan when they detect certain malfunctions. So, they're keeping up to date. Now, the emerging space power here is India, and they are designing their own spacesuits, but I think they don't want to take a risk right now. So it looks like right now they're using the Russian one. So they've actually sent people to get measured because they're very custom tailored to these kind of things, get measured and trained in Russia, even right now, I think, because they have a mission coming up in 2026. You don't think of them as having manned missions. They're doing a 3-day mission in 2026. Not a space station yet, but they have that planned.
The Russian suits are, the traditional design for these is you've got a back door, basically.
Yeah.
That backpack basically opens up like a giant door, and then the astronaut crawls in feet first, and then bends over, and then pops his head up into the helmet, and then someone else closes that backpack in on his back.
And I think the Chinese ones do that, and I think the new Axiom ones do that as well. And
it's pretty fast.
Yeah, it's much faster to get into it, and that's a big advantage. So I think that's the way that they're all going. Actually, the Russians had the right idea on this one. Okay, that's it for the main topics. Just a couple of things on notable launches coming up. We already talked about the Starship Flight Test 6. We haven't talked about Blue Origin. Their New Glenn, which is their big Starship competition, that might go up this month. Now, that's had a lot of delays before, and it may go up. Originally, they were going to have a couple of small Mars satellites were going to go up with them as part of that launch to tag along. That got delayed just because the launch window closed, and they probably weren't going to be ready. One new thing that came out recently, though, is they are going to be landing on a barge. They're going to do the kind of thing that Falcon 9 does. They're going to land on a barge instead of going all the way back. So whether they do that on the first test or not, I don't know, but they might. It's actually conceivable. They tend to play things so close to the vest, you just don't really know. We talked about the Rocket Lab Venus mission and the intuitive machines. Amazon's Kuiper project. This is the one where it's going to be a Starlink competitor, thousands of satellites up there for communications. And of course, that's taken them forever. Their first operational launch, actual operating satellites besides the tests that they've done, should be going up sometime first quarter. So it's coming. Dream Chaser, we talked about that one before too. That's a space plane, but they're still hoping to use that at least for cargo on the space station.
Clarification is they were supposed to launch basically like last month, but there was either a problem with the booster or the Centaur, or what was the problem with the Dream Chaser? Which one was?
Yeah, I've lost track. I'm not sure. And of course, the big one coming up is Artemis 2 eventually on their journey around the moon, and we can't tell what that's going to be, or when that's going to be. No, that was interesting. NASA, okay, we're talking about the heat shield for Orion, is what you're talking about. Yeah, Orion is a spacecraft that the astronauts go from Earth orbit out and come back. Then they go down using a Starship and back up, coming back on Orion. It's a very complicated system. Anyway, when that one, in their first test, when they brought it back to Earth, they kind of kept it a secret for a while, but there were huge potholes in it, essentially, in the heat shielding. Apparently, big chunks of it got torn out, and that raised a big concern. So NASA has announced that they have figured out what happened, but they're not saying what yet. They said they want to do a little further analysis and testing. So you kind of wonder what's going on there. We'll find out. I mean, it's quite possible that by the end of the year we'll know more about this, because it impacts a lot what's going to happen. Because if they have to really build a whole new heat shield, that delays the whole program quite a bit, especially if they're redesigning it. So it's not clear what will happen there. So it's fraught with peril from NASA's standpoint in terms of schedule risk, and hence political support and all that. So Yes, that's it. Now we have a world famous author with us today, Vickie Kloeris. She's right here, and she's worked basically for a long time at NASA. She probably doesn't even want to say how many. It's 34 years, But she actually managed food for the shuttle and the space station. I mean, this is the the expert, the world's expert here on how do you do that. Actually, I'm hoping to hear some recommendations for what airlines ought to do about their food. I mean, they're up there not as high, but they have a problem. Okay, yeah, she's won all kinds of awards and so on, and she went to Texas A&M, bachelor's and master's degree. So, you Aggies out there, you'll definitely better pay even more attention than you were going to before. Okay, I'll turn this over to you.
I want to start by thanking you for inviting me to speak today.
We're glad you made the journey up there.
Yeah, we're definitely.
We're glad you made the journey up there. So it's not a short trip.
That part.
Yeah.
It's not too bad.
Yeah. I want to say she's
my
actually.
sister lives right around the corner, right off of Cypress Wood, but she's actually out of town. Otherwise, she would
Oh.
today.
Well, then you should come more often and bring her along. Yeah.
Okay, so
Okay, I should have mentioned she's actually given a talk to us before, some years ago, but it was only a Zoom meeting. Now you have the real thing.
how do I get this one?
Oh, also you need a.
Oh.
Yeah, this is the microphone part is on top. You just clip it to anywhere there. You put it in the center, that way we can turn your head.
There we go. All right, let me see what I got here. Oh, okay. This is the end. I've got to get back to the first. Let's see if I can do that without showing all the slides to get back there. How do I do that?
I think the trick is clicking in the display.
Okay.
I had this problem before too. Oops.
Okay, so yeah, it says end.
Yeah, I don't want that. Let's just try it up again.
Can you up and when you get to that white thing?
You know what?
Like, can you?
I'm at the end. Oh, that's,
Yeah.
Oh, I started at the end. Okay.
Yeah.
We should start at the beginning. I think that's rule number one. Anybody should be able to follow. Okay. I think that should do us.
So I think this is how I start my talk, and you got to understand I'm usually presenting to people who don't know a lot about space, so you probably already know this. But what I tell people here is this is a picture of space station at assembly complete. It was taken on one of the last shuttle missions, but it gives you an idea of what station looked like. And to remember that station started out as 2 modules that docked in 1998, and it wasn't until the fall of 2000 that it actually expanded enough that it could support people, but that they could leave people behind. But so we've had, station continuously crewed since the fall of 2000. So long time. A lot of people, it's amazing how many people don't realize that, how long we've had crew members up there. And I always also tell them that I've been told to give them an idea, if you laid this on an NFL field, it would stretch end zone to end zone. So that gives you an idea of how big it is. And that the internal usable volume is now about that of a 3-bedroom house. So that gives you an idea of how much room people who don't have any concept of, what it's like. So I managed the food system for 29 years, worked with the food system for about 34 years. And so what I'm going to talk about is the current food system that they have, NASA's providing to the ISS. This is what the beverage package looks like. So we devised this package in the early 90s. Way before that. Because the original packages that were used on the shuttle were rigid plastic packages. They took up a lot of room in the trash and in storage to get to orbit.
They were designed to nest inside each other, so they made stacks, but they took up a lot of room. And so when Challenger happened and we had the downtime, we were directed to come up with packages that took up less volume. So we had a packaging engineer working in the food lab at the time, and we came up with the design for this package. So the material that it's used is actually, let me see if I can figure out how to do the pointer on here. Uh-oh, I did something really bad. It's way toward the front, you said? Oh, there it is. Okay, so this adapter in the top of the package contains a septum. The septum used to be in the corner of that rigid package, but the septum has a little plastic valve in it, and it's got a slit in there, and it's what allows the water to be injected from the galley into the package using the needle on the galley. So they inject water and then shake it up, and then in order to drink, they have to insert this straw into the package. The straw has a rigid tip to hold that slit open so that the fluid can flow out of the package and they can drink it through the straw. But in between sips, they've got to clamp it closed. And that's an off-the-shelf IV clamp. And otherwise, that fluid's going to form a big ball on the top of the straw and make a big mess when it gets knocked off. So that's how all the packages are done. And it's funny, when we came up with the design, the engineer said, oh, you got to have these things to protect, because if you got hot coffee in there, and they flew maybe 2 flights on Shuttle, and then the astronauts came back and said, no, you're crazy. In microgravity, you can hold it by the edge of the package. You don't have to put your hand around the hot package. So those went away pretty quickly. And the original material that was used was the same that Capri Sun was using at the time. So we bought the package. It was sealed on 3 sides, open at the top. And there's a custom piece of equipment that seals that adapter into the top of the package. This is the freeze-dried food package. The same adapter is available. And in this case, they're going to inject the water, and the label tells them how much water to add. In this case, this is cashew chicken curry, 100 milliliters hot water, wait 10 to 15 minutes for it to fully rehydrate. So they inject the water, then they're going to cut the package across the top and eat out of the package with a fork or spoon, depending on the product. You can see that we have a barcode on the package. The barcodes were added pretty early on because they started flying experiments on the shuttle that required the astronauts to keep an exact dietary record of what they had eaten during the days that they participated in that experiment. And when they first started out, they were literally using a pen or pencil and paper to do it. And the crew member said, this is nuts. We got to have a better, it's too much trouble in microgravity to try to do that. We got to have a better way to do this. So we started putting barcodes on the package. And at that time, they had this huge handheld thing that they read the barcode with, Now there's an app for that. There's an app for everything. So now they have an app that does all their dietary monitoring, and they scan the barcodes. But at the time that we did institute the barcodes, we made them smart barcodes, meaning the first part of the barcode, even if if all you had was the barcode, the first part of the barcode would tell you what the product was. So it's unique to the product. The second part of the barcode is unique to that individual package. So just like in the food industry, if something happened to one of the lots, we could do a recall, just like the food industry can. So, if there was ever a problem, food safety wise, we could tell them, here's the barcodes you need to not use. Fortunately, during my career, and to my knowledge, we've never since had to do that. But we do have that capability available.
E. coli in space?
Yeah, E. coli could be in space, yes, for sure. So you also notice, I don't know if you can tell, but there's Cyrillic on the package. So when we started working with the Russians in the early 90s and we were going to send our food to Mir, they insisted that there be Cyrillic on the label. And it was probably necessary early on because when our folks first started working with the Russians, they didn't know the other's language so well. Now it's kind of ridiculous because, the folks that go to Russia, they learn to speak Russian and the cosmonauts learn to speak English. And the way it works on station is the Russians provide food for the cosmonauts. NASA provides food for everybody else that's on orbit. That's just the way it was set up. The Russians insisted on continuing to provide all the food for their folks because they have a dedicated company in Russia that does that. And so they were protecting that company. And so, but the use of the Cyrillic led to some interesting situations because, for instance, when we have a product in the menu called Fiesta Chicken. Now, most people in the U.S. would know that that means it has southwestern spices, right? When we presented it to the cosmonauts, they looked at the name and said, "What is the party chicken?"
Yeah.
And they have a product that when it's translated into English, it comes out appetizing appetizer. So it tells you nothing about what the product is. So the translations led to some interesting situations. It was actually a mushroom. Yeah, it was a freeze-dried mushroom, I think.
It was
Yeah.
an appetizer?
Yeah, it was supposed to be an appetizer in their menu, yeah. So, thermostabilized foods. I'll mention a lot of people that I encountered during my career thought that all the food they ate on orbit was freeze-dried, right? And a big percentage of it was, especially in the early flights. But not so much anymore. It's about 25% roughly of the current space station standard menu is freeze-dried. And another about 25% is thermostabilized. And so the thermostabilized products, when I first came to work at NASA as a contractor, the shuttle was early. 16 of the 135 flights had flown. And so they were using MREs. They would buy whatever entrees the military was making in the pouches, and they would send those to orbit. And that was fine for the short shuttle flights. When we went into the International Space Station, I was actually hired as a contractor in 1985 to help design the frozen food system for Space Station Freedom. We were going to have a U.S. only space station, and that quickly went away. They quickly realized they were never going to have the funding to be able to do that, and so the International Space Station was born. But so we were going to have part of the ISS was that we were going to have freezers and refrigerators for food. But when the engineers started, we were going to have freezers and refrigerators for food, but pretty early on in the program, the engineers came to the ISS management and said, "Look, we're looking at the power we're going to get for the solar arrays. You can either have freezers for food, or you can have freezers for science." And so we were back to an all-shelf stable food system. So thermostabilized wise, that meant the MREs had to go away because they're real high in salt and fat, both of which the military has good reason for having the high salt and high fat. They want the food to be really calorically dense, thus the high calories, and the salt is necessary for the soldiers that go out in the desert and sweat out all those electrolytes. They need all that back. But the high sodium especially is really bad for microgravity for long duration because it exacerbates bone loss. There's already a tendency to lose bone in microgravity, and high sodium makes that worse. So if you and I as we get older, if we get osteoporosis, our doctor's going to tell us, don't eat so much salt because it makes it worse. And so we knew we had to start making our own thermostabilized products because we weren't going to have the freezer. If we had had freezers, that would have helped us produce items that were lower in salt. But we had to replace the MREs. And so now there's about, I think, 50-something different formulations that NASA makes custom in the pouches. And those are actually made at Texas A&M University. So their retort facility, it's a long story. When we first started making these products, we would go into the MRE facilities and we would rent them for a week or two at a time, and we would make everything we needed for like a year or a year and a half. But then the first war in Iraq came along, and it persisted for so long that they were making MREs 2 shifts a day, 364 days a year. We could no longer get access. So we had to come up with our own retort facility. And so we put out a RFP, a request for proposal, had several different bids on it, but actually Texas A&M won the bid. And one of the reasons they did was logistically it was close enough to JSC to be able to easily transport stuff back and forth. But so that facility, that retort facility opened in February of 2007, and we have a dedicated food scientist from NASA. It's a contractor, but they're, yeah, what were you going to say? Oh, okay. I'm sorry. A retort is the piece of equipment, and I can't remember. I may have a slide in here of it. It's like a big autoclave, if you're familiar with an autoclave. Okay, so it's a big piece of equipment, and these MRE contractors would have 20 or 30 of them in their facility. So we could go in and make a ton of food in a week because they had so many retorts. We installed one retort at A&M, just one. And so we have 2 here at JSC, but the flight food is produced mostly up there at the A&M facility. And what happens is the food is sealed in the pouch. You prepare the food, you seal it in the pouch or the can. This is just like canning, like you have in your commercial cans in your pantry at home. The product is sealed in the container. The container is put in the retort. The retort uses a combination of heat and pressure to sterilize the food. So it basically kills all the bacteria inside the food. What comes out, if the retort is run properly, what comes out is considered commercially sterile. So the food is, and as long as you don't have a hole in that can or a hole in that pouch to let air in, no bacteria is going to be inside. So we make those products up there. There's a resident food scientist from the contract who manages the operation and uses student labor at A&M. Typically, it's food science and nutrition students who sign up, but it's like a paid internship. They get paid to participate. Yes?
You say thermostabilized food.
Yeah.
If we talk about refrigeration, does that mean
No. Thermostabilized means made stable by heat. So it's just like canned. It sits in your pantry. It requires no refrigeration. Has a long shelf life at room temperature. Yeah. Yeah.
Sort of like being pasteurized in the can.
Yeah. Yes.
Yeah.
Except it's even more extensive because pasteurization doesn't make it sterile, and this actually makes it sterile. There's intermediate moisture foods in the products. These are like dried fruit, dried beef, things like that. And then a big chunk of the food is called natural form because it flies in its natural form. Nothing's done to it other than to repackage it. And there's a few reasons that's repackaged. One is to get it into a portion size so that we know how many calories they're consuming, what other nutrients they're consuming. Another reason it's repackaged is because all this stuff is dry. And if you send it up in bulk, it's going to float. You open a bulk package of something like this, it's going to be almost a pain in the neck to handle in microgravity. So putting it in, huh?
The Jack in the Box.
The Jack in the Box effect. Yeah. Yeah. So putting it in single serving makes it much easier. They just cut across the corner with the scissors. They can work a few out at a time. Much easier to handle. Also, that material that it's packaged in is pre-approved for the spacecraft environment. So rather than having to test all the different packaging materials, this is pre-approved and it saves a lot of money that way because you don't have to test all the different off-gassing of all the different materials.
Just get the big.
Yeah, off-gassing is the problem.
A lot of people I don't think understand.
So it's all about the chemicals that the material gives off. And because it's in a closed environment, and that's what the astronauts are going to be breathing, then they have to know exactly what chemicals it's giving off. And basically, if you're using a food approved material, there's not going to be an off-gassing issue, because in order to be approved to package food, it's going to meet the off-gassing requirements. But still, you don't want to have to test all the different manufacturers' packaging, so it's much cheaper to repackage. There's also a few meat products there's about 4 left, I think, that are actually, instead of going through a retort and using heat and pressure to make them sterile, they have been irradiated to make them sterile. The advantage of these, and we have special permission, NASA does, through the Code of Federal Regulations to produce these items, because irradiating food to a level of shelf stability in the U.S. is not approved for commercial use. You can irradiate, for instance, they can irradiate strawberries out of the field to kill some of the bacteria that are on there to increase the shelf life, but it doesn't make them shelf stable. But the advantage of doing this, and in other parts of the world, it is approved to irradiate food to a level of shelf stability. But the advantage of doing this is that you can do big chunks of meat instead. Like most of your canned meats, the meat's going to be cut up in little cubes, and that's so the heat can penetrate and be sure that you killed all the bacteria in the meat. The radiation will penetrate further. And so it allows, for instance, one of the products they have is an actual intact beefsteak. And it's very, very popular, but it would not be commercially sterile in a retort, but it is commercially sterile through radiation. Condiments are a big part of the menu. On Shuttle, we used to fly the little restaurant stall packs like you get at the fast food places. But now on station, because they're up there for so long, we can send, and there's large enough crew size, they send plastic bulk squeeze bottles of condiments now. So mustard, mayo, hot sauce, all those kind of things. The only thing that's really different is the salt and pepper. It has to be in liquid form. So you really can't have salt and pepper floating around and getting into their eyes or breathing into their lungs. It could be a real irritant. So the salt is dissolved in water. Their pepper's dissolved in a food grade oil similar to a cooking oil. And it's in a dropper bottle. They shake it up. They squeeze a drop and touch it to the food. So the whole issue with sensory on orbit has always been a problem throughout space food systems. So when you go into microgravity, all the fluid in your body shifts to the upper part of your body. And they used to make jokes about having chicken legs on orbit because their legs would visibly get skinnier with the fluid shift. And they also talked about, on the shuttle, the crew members would talk about one of the first things they had to do was get the potty going because their body would start trying to eliminate fluid because all your sensors for fluid are in the upper part of your body. So when that fluid shifts, your body's saying, you got way too much fluid. And they get real puffy faced and all congested. So it's like when you and I have a cold down here, it affects how our food tastes. Because when we're congested, we're not getting aroma through the back of our nose like we normally get. And so that either makes the food taste different or make it taste like nothing, like cardboard if you're really, really congested. And so they were experiencing the same thing on the shuttle. So one of our most popular items on the shuttle, and it's still popular, was our freeze-dried shrimp cocktail, because it was freeze-dried shrimp with a powdered sauce, tomato-based sauce, but it had horseradish in the sauce. So it had a nice little kick. So it was very popular with the crew members because they could actually taste it. And on station, it's still a bit of an issue, not as much as it was on shuttle, because when they're up there for a while, eventually the fluids equilibrate and they're not quite as puffy and congested. Their body will get rid of excess fluid. So, but they're eating out of packages instead of off a plate. And so that fact interferes with their ability to get aroma from the food. Plus, when you heat stuff down here, all the heat rises, the aroma comes with it. On orbit, it can dissipate in different directions. So you're further losing aroma from the food. And they're in a closed environment with other competing odors. So all of that taken together, it's not surprising that a lot of them report that they feel like their taste buds are somewhat dulled on station, and so they still like the hot sauce and the spicier items quite a bit. Uh-huh.
So say, for example, food that would have a pepper crust on it,
Mm-hmm.
right? Like, when you ate kind of that meat dish, like capsaicin type sensation
Uh-huh.
that a hot sauce would create. But it's pepper. Like, you're showing here that it has to be in a liquid form,
Right.
right? So, like, this food would not be able to make it.
Well, I mean, the struggle is always to be able to deal with crumbs and stuff that come off the food, because the crew members don't want to deal with that. It's a pain to deal. They always talked about how if you made the mess, you had to clean it up. A perfect example was when they came out with Pringles. So we never flew potato chips in a bag, just no protection. They would be mush by the time they got to orbit. But when Pringles came out, a couple of the shuttle crew members were like, I want to take, I want to take Pringles in the fresh food tray. And we tried to caution them against that. We said, look, yeah, it's in a can, but there's a lot of crumbs in the bottom of that can. And so, but we let them do it. We didn't forbid them from doing it. So we flew some of the smaller Pringles cans in the shuttle fresh food tray. After one or two flights, they came back. Oh, no, we should have listened to you. That was way too big a mess. Had to clean that up. So anything that's going to create crumbs is a problem. And so you're going to have to manage that when you deal with trying to develop products to send into space. And my next slide is a perfect example. So this is our split pea soup that's thermostabilized. And I put this in here to show that when they're developing products for space, they have to consider the viscosity of the product. It has to be thick enough that it can stick to the package or stick to the utensil. Otherwise, it's going to be a nightmare to handle in microgravity. So viscosity is always an issue when they're talking. For instance, we do have a chicken consomme that's part of the menu, but it has to be drunk through a straw. It's packaged in one of those packages, and they have to insert a straw and actually drink it because they can't handle it opening it. And that's one of the big things that some of these commercial companies who are talking about, they're going to put up private space stations, and more power to them if they can. But a lot of them have said, we're going to have traditional cooking and stuff on board. And it's like, that's going to be really hard to manage in microgravity unless you could, until you have a way to really have gravity on some of these spacecrafts, it's going to be very difficult to do any like traditional type food preparation. All they're doing is adding water and warming stuff up. They're not really cooking. In fact, they don't have anything that gets hot enough to cook anything. All they do is warm up pre-cooked items. Flour tortillas are the most popular bread item in the NASA food system. So when I came to work there, we were sending fresh sliced bread in the fresh food tray to orbit for them to make sandwiches with. Well, shortly after I came to work there, Rudolfo Neri from Mexico flew as a payload specialist on board the shuttle. He wanted to take corn tortillas in the fresh food locker. We said, fine, we sent corn tortillas. When the astronauts saw how easy it was to take something, roll it up in a tortilla, and it was like having a sandwich without having to deal with 2 pieces of bread, they're like, forget the bread from now on. Let's go with tortillas. And you have to remember when this was. This was 1986. This was before there were breakfast tacos everywhere, and all us gringos knew about tortillas, right? So they wanted to take flour tortillas. And so we went out, basically what we did, we started looking around the launch site in Florida, and there really weren't any manufacturers in that area. Lots of them down by Miami and stuff in South Florida, but not so much around Cape Canaveral. So, but there were plenty in Houston. So we went and took samples from a bunch of them, found the one that had the lowest yeast and mold count, because that's how they're going to go bad. They're going to mold or they're going to get yeast on them, and found the ones that had the best and bought them. And so when the crew would leave from Houston to fly down to Kennedy, the morning they were going to leave, we would go buy fresh tortillas off the production line, put them on the plane. They would go down, and that was what was stowed in the fresh food locker. And that worked for quite a while. But then when the shuttle flights started getting longer, further out, the crew was like, well, we really want to have tortillas that last all the way to the end of the flight. Well, the military made what was called, and still makes, what's called extended shelf life bread products. They make bread products, and it's actually a company in San Antonio that has the contract. It's called Sterling Foods, and have had it for years. They make these bread products, they package them anaerobically, no oxygen in the package. So yeast can't grow, mold can't grow. So they last a long time. 2 years is what they get out of their extended shelf life bread products. But there's always a catch. And the catch is you can't just take regular bread dough and put it in and store it anaerobically, because anaerobic pathogens can grow, like Clostridium botulinum. So pretty nasty stuff can grow. So the way they get around it is they put a binder in the dough that reduces the amount of free water in the dough. If you get the amount of free water below a certain level, nothing can grow. Anaerobic or aerobic, nothing can grow. So we knew the technology that they were using to make these ESL, extended shelf life breads, but they didn't make a tortilla. So we, in the food lab, developed our own extended shelf life tortilla. So we were in the tortilla manufacturing business for several years. Tortilla, the dough divider, dough press, the whole bit. And ours would get a pretty good shelf life, about 4 to 6 months, but then they kind of developed a bitter aftertaste. Well, it didn't matter. 4 to 6 months for Shuttle was more than enough, because we could make them right before the mission. Well, then when we went into space station, we're like, okay, we got to have more than 4 to 6 months for station. So we were about to start doing a project to figure out what's causing that, bitter aftertaste, how can we get a longer shelf life? And about that time, a company, and I think it was Taco Bell, came out with a soft taco kit in the grocery store that had tortillas in the kit, and it had a 9-month shelf life. We're like, that's got to be a low water activity tortilla. That's the only way they could get that kind of shelf life. So we got samples of it, tested it, sure enough. So we just started buying it from the people, the bakery they were buying it from, and packaging those. And we were getting a 2-year shelf life, which was perfect for station. Well, a few years ago, the military started making an extended shelf life tortilla. and packaging it as Sterling Foods did. And they finally, there's so many Hispanics in the military, I'm sure there was a great demand for tortillas. So we got some of those samples into the lab and said, okay, we're going to compare them to ours. So we did a blind taste test. Some people thought ours were better. Some people thought the Sterling was better. Some people said, can't tell the difference. Well, the truth of the matter was, when we investigated, Sterling wasn't making them either. They were buying them from the same people we were buying them from and packaging them. So now NASA buys them pre-packaged and sends them to orbit. But you never can get enough tortillas up there. They're extremely popular. Yes.
Does the addition of that binder change texture?
It does a little bit, yeah. I'd have to be honest and say, yes, it does a little bit. But like I said, yeah, you got to get the water activity down so it can be safe to package it anaerobically, yeah. This is a bulk overwrap bag, or a BOB. At NASA, got to have an acronym for everything, right? So the NASA sends up BOBs of food to orbit. To give you an idea of the dimensions, it's about 15 inches by 12 inches by about 6 inches deep. If you packed by meal in here, like breakfast, lunch, dinner, you could get approximately 9 meals in here. So that would be food for one crew member for 3 days. But that's not the way it's packed. So it's packed what we call pantry style, meaning all the meats are together, all the veggies are together, etc. So there's 8 different categories of food, and they have one of those 8 open at all times on orbit. So even though NASA is using a standard menu, meaning the contents of those 8 containers are the same every time. Every meats container that they produce is going to have the same set of meat in it, but the crew isn't having to eat per menu. They just, when they get ready to do a meal, they go to those 8 containers. They go to the entree container. They pull out what they want, what they feel like for that meal. So they create their meals real time from a standard menu. When on Shuttle, we did a 100% personal preference menu. The crew members would come in, they'd look at the food list, they'd say, day 1, here's what I want for breakfast, here's what I want for lunch, and that worked great on Shuttle because the food and the crew member were never separated. That did not work at all when we got to space station because the food was going up on cargo vehicles and the cargo vehicles would slip. And then the crew members would come back and said, you promised I was going to get what I selected. And part of the time I was up there, had to eat Joe Blow's food, and he had terrible tasted food. So it became a big issue. A big psychological issue with the crew members. And so when the ESA was going to fly a brand new cargo vehicle for the first time, and the name escapes me now. I've been out of the biz long enough, I can't remember. But they had an unmanned cargo vehicle, and it was the first flight. And NASA wanted to load it up with clothing and food. They didn't want any one-off science equipment on there in case it didn't make it. So we had no idea. It kept slipping. And they wanted the food 9 months in advance of the launch because it had to go to Europe, and then it was going to go to South America to the launch site and be launched. And so they wanted it like 9 months in advance. So we talked about it in the lab, and we created a standard menu, basically took all the foods with as much variety as we could create and created the standard menu, took it to the astronaut office and said, look, this is what we want to put on that vehicle since we have no clue who's going to be on orbit when this vehicle gets there. And much to my surprise, they came back and said, not only do we want you to use that vehicle, we want you to use this standard menu from now on. And so, but the negotiation was that they would get a few preference containers. So now a crew member that's on orbit for 6 months is going to get 9 containers like this with their name on it. And they get to choose what goes inside those 9. They're going to get 9 for food and 5 for beverages. And mainly for the beverages, that's so they can have customized coffee and tea and things like that. Because on orbit, all they're doing is adding hot water. So we would have to ask them ahead of time. You want it black, you want creamer in it, you want artificial sweetener in it. So it had to be ready to go. They just put the hot water in. So 14 containers that are custom for that crew member. That is much easier to assure that you get there at a proper time. If you were doing their entire menu for 6 months, it would be closer to 80 containers of food, which is just, you can't manage that, especially not for multiple people. So they do get 14. The food that they put in there, it can be more of our goodies. If they have something they really like, they're going to have to put extra in there because those 8 categories are being shared with all the crew members, and there's not going to be very many servings of anything in those containers. Or if they're a ESA, JAXA, or Canadian crew member or another country, their country can provide items for NASA to pack in the preference containers. So, as long as it meets the shelf life and microbiological requirements and no glass, we can't send anything to orbit in glass. This is a picture in the actual food lab. We do food sessions with the crew members so that they can try the food. Otherwise, for space station, they see the flight food one time in a galley training class. That's it. They get one meal during that galley training class. If we didn't do food sessions for them, they really wouldn't see the food till they got to orbit. So they come at lunchtime and come about 4 or 5 times so that we can let them try everything that's part of the NASA menu. Each crew member gets their own utensil kit. That's because they cannot truly wash or truly sanitize on orbit. They just have like antiseptic wipes that they use to wipe it off, but we really don't want them sharing utensils because they're not truly sanitized. This is a close-up of a picture of the galley on orbit. So what you see here is the actual rehydration station. So this dial is where they dial up the amount of milliliters. They choose either hot or ambient water, which are their 2 choices on ISS. And then the needle injects the amount that they've selected. These 2 here are actually small chillers, about the size of typical home microwave, each one. So they do have these chillers to chill beverages. Since they don't have chilled water on orbit, if they want chilled beverages or if they want some of the pouched fruit to be chilled before they eat it, they're going to put it in these chillers. If they, chilled beverage after exercise, they're going to have to plan ahead, prepare the beverage, put it in there so it'll be chilled when they're done. Down here are the 2 warmers. And I have this is a close-up of the rehydration station. This is actually in a trainer on the ground, but the needle is inserted into the package, and over here is where they selected whether they wanted hot or ambient water. And this is a close-up of the warmer. So it's a conduction type warmer, 4 vertical hot plates with clamps, and they actually clamps the item to the hot plate so that it warms up. This is actually one of the Russian cans. Much to my amazement, the Russians still use a lot of cans in their food system, which is very surprising because they're very heavy. That's why the military wanted to get away from them. That's why they came up with the MRE pouch. That's why we wanted to use the MRE type pouch, is to any amount of weight you can save. We've heard all this discussion today about weight and fuel and all that. So weight is very important. I think it's just the technology that particular company, they have a dedicated company, and for whatever reason, that company has not gone into pouches. So they've stayed with the cans. And I mean, it could be that the engineers just feel like that's better protection, the can maybe, but we haven't really had, pouch failures. That hasn't been issue launching pouches into orbit. Perhaps they're concerned that that might be a problem, and that's why they want to stick with the metal cans. I don't know. I can't really answer that. This is, oops, I messed up. This is the dining table. And so this is interesting. This is about the third iteration of the dining table they've had in the U.S. segment. When station first started, all the dining was done in the Russian service module. But as the crew size increased, they needed a second food preparation area. They added one over in the U.S. segment. And like I said, probably the third iteration of the dining table. This one is interesting. It folds out. In this picture, it's folded up, but it folds out. And of course, it's got lots of Velcro and straps to help retain the packages. But the interesting part of this is that it was designed by high school students. So NASA, the Hunch program, if you're familiar with that, High Schools United with NASA to create hardware. This was actually produced as part of the.
Everybody might remember the presentations I did on that.
Yeah. So this was actually the Hunch dining table. Yeah.
Because I think not actually, somebody built that too.
Oh, nice.
And his signature's on the bottom side of it.
Cool. Yeah. So anytime fresh food arrives to station, it's like Christmas. It just is, because they don't get it very often. And anytime that now that there's late access to a cargo vehicle, whether it be the Progress or it be the SpaceX cargo vehicle, if they could get late access within a short time of launch, they're going to try to put some fresh stuff on there. Typically things like apples, oranges that'll last a while without refrigeration. This is a picture of Sergei Krikalev. I include this because he was the first cosmonaut to fly on the shuttle when we started doing the Mir program. We were taking him, this is in the early 90s, we were taking him to station. We were going to retrieve a cosmonaut. So this was the first time they did one of the switch out missions on Mir. And now he's the head of Star City. This is my understanding, is he's the big dog in Star City now in Russia. But I put it in there because it shows the international flavor, you know, a cosmonaut eating Japanese rice out of a pouch with chopsticks. Yeah. So.
And his rice.
Yeah, it's Japanese sticky rice though, so it makes it a little easier to handle.
Astronauts playing with their food.
Yes, they do. They often do. So this was sent to me by a crew member from orbit via email. So this is the wheat flatbread, which is one of the military extended shelf life bread products. And he added our squeezed cheese and some olives to make, it's his version of a smiley face. He was sending it to us to thank, he wanted me to pass it on to the team to thank us for some of the special things we did for his fresh food locker. So Mars or bust, that's the whole goal that NASA, and even so this picture was taken in a chamber test that I did in 1997. So I spent 91 days in a chamber at NASA. It was one of the chambers that had been used in the Skylab test. And there were 3 other crew members. We were testing air and water recycling systems. And at that time, it was all the talk was Mars or bust. But we were told, you do not, because we were doing a lot of interviews and a lot of, public affairs stuff while we were in the chamber. And they said, you do not mention Mars. You got to remember, this was before station was going. And they're like, no, we don't want Congress to hear anything about Mars. We're focused on the International Space Station. So when Halloween came, we were in the chamber from September to December. When Halloween came, the 3 engineers that were in there with me, they were determined that they wanted to promote the Mars or bust, and so we did. I wrote a book about my career. It's called Space Bites, Reflections of a NASA Food Scientist. There's a card on the table at the back with a QR code and link to a website where you can purchase the book. And I wrote it for several reasons. One, I wanted to honor my mentor and first boss at NASA who passed away in the fall of 2019. And so I wanted to honor him. And I also wanted to make students aware of food science as a career path because I flat stumbled onto it when I was in an undergrad. So I was a microbiology major at A&M. And when I got ready to register for my last semester as an undergrad, I was 1 hour of micro short, 1 hour of micro elective short. And on the list, and my advisor in the College of Science was like, oh, just go to one of your profs, do a white paper, for 1 hour. But on the list was this food microbiology course. And I thought, I want to take that. I'm interested in that. But it was over in the College of Ag, not in the College of Science. And so it was approved, but he tried to talk me out of it. Why would you want to do that? It's 3 hours plus a lab. It's 4 hours altogether. Why would you want to do that? But I was really interested. And when I took the course, I became super interested in the application of micro to the processing and preservation of food. So went into food science for my graduate work. And got my first job in Houston with the Memorial Hospital System. This was back in the day before it was Memorial Hermann, but Memorial had a cook-chill food facility where they made food for 5 hospitals in the area. And so I was doing quality assurance work, basically food safety work for them. And I had joined the Institute of Food Technologists, which is the IFT, the professional org for food science. They're headquartered out of Chicago. I had joined them in graduate school, but they had a local chapter here in Houston, kind of like you guys have a local chapter. I went to one of their meetings, met some of the food scientists working down at NASA, and I thought that has got to be the coolest job a food scientist could have, feeding astronauts for a living. So I said, if you guys ever have an opening, call me. And they did. About 2 years later, I got a call and went and interviewed and went to work in August of '85 as a contractor and worked for 4 years as a contractor. And then Rita Rapp, who was the civil servant manager of the Shuttle food system, unfortunately got cancer and passed away. And so I transitioned over and that's when I became a civil servant and managed the Shuttle food system and then International Space Station when it came on board. So, but students don't really know about food science. They know about culinary and being a chef, and they know about dietetics and being a dietitian, but food science is different from both because food science is all about the processing and preservation of food, especially commercially. And so food scientists work for food companies. They work for the government, USDA, FDA, state government, all the regulatory. There's a lot of demand out there for food science, and a lot of students don't know about it. So that's one reason I wrote the book. I wanted that. And I wanted people to be aware that there's more to NASA than just astronauts and engineers, that it takes every discipline to do successful spaceflight. Okay, I have talked way too much. Yes?
And I understand you worked a lot with them. There's a lot of high schools
Yes.
doing these recipes.
Yes. Yeah, we did a lot with the Hunch program, quite a bit. Yeah.
So how did that work? Any stories there you want to tell?
Well, usually, I mean, the Hunch, the finals for that were usually done at Space Center Houston, and our main interaction was to help judge the competition. That was our main interaction with them and we kind of served as advisors if they had questions, along their path of developing their products. If they had questions, we would answer the questions. But our main involvement was actually
So the
judge.
must have had a recipe how to do this for the kids?
Yeah, I mean, sort of. But in some sense, it was more euphemistic than actually, because they didn't really have access to a retort or to to a freeze dryer, and so it was more creating the product. It was more the concept of doing it than the actual taking it all the way to conclusion. Yeah. Yeah. Any other questions? Okay. If not, thank you. Appreciate it.
Not sure if
Ah,
a little star show.
you didn't have to do that.
Oh, very nice. Thank you. Very nice.
Also, I got a card
I
got 4, so I thought I'd give them away. So I got some questions maybe to help me with this. So, what is the most popular bread product on iTunes?
Tortilla.
Tortilla. Okay, very good. Okay. What does Bob stand
Just got the bus.
Okay, maybe a different question. Full overwrapped bag.
Yeah, full overwrapped bag. Yeah.
What's another good question?
What percentage of the current menu is freeze-dried, approximately? Yeah, 25%.
Yeah, I got 2 more.
Okay, why did NASA have to start developing custom thermostabilized products?
Because of the Iraq War.
Yes. And too much salt in the MREs, yeah, but because of the Iraq War, yeah.
I got 1 more.
On the Starship story, I will say, I've been asked so many times. No, because Sonny and me are having to stay up there so much longer. I said, no, that's really not an issue because they always keep about a remote reserve. I said, the big problem for the 2 of them is clothing. They weren't, they don't have a way to wash clothes and they weren't expected to be there all the time. And the exercise, the shoes, the exercise equipment. You have to have custom shoes to interface with the exercise equipment. And when they were going to be up there a short time, they didn't bother with that. But now, they're going to be there so long, they have to be able to exercise. But food wasn't a problem.
Or they just not exercise. No, that's not an option either.
No, not if you want to be able to walk when you do that. You want to be able to exercise. One more question. What should I
So, what is the little plastic thing that's in the top of the container that's used to put the water? But then, the thing is, you put the needle in.
You remember what I called it?
Yes,
Septum. That's right.
We did it. And if we could take a group picture real quick, then I'll turn on the lights and we'll get the people online up here. And I'll find somebody outside to take the picture so that. So if y'all can turn on your cameras, that would be useful.
Yes, I could have done another half hour on the issues of Mars. The shelf life.
Yeah, I'm gonna send you the
It's probably gonna have to be pre-positioned, and, with the.
Oh.
Yeah, oh, cool. So many people bring up their, I didn't even talk about that.
Times 1.
Thank you very much. That's fun.
Thank you online. We're going to go ahead
Okay,
and
so let's see, that's one mic. Where's the other one?
it's in my pocket.
Oh, okay, good.
No, it's
Let's see, who
it
has?
must be